All right, here's hoping that we're going to get a quicker second half. That was a longer video. Sorry about that. I know it's hard to watch a 20-minute video, but hopefully you fast forward through what you need and that kind of stuff. But here we are on question number 7. We're talking about going upside down on a roller coaster. We want to know things like, what are the relationships that have to exist to make sure that I don't fall out? And the premise is that in order to travel in a circular path, the seat has to push me out of my seat or towards the center of the circle with a force that's equal to a centripetal force, or in other words, mv squared over r. Now, if I want to do this where there's no chance of me falling out, right? There is a speed at which basically as I free fall out of the chair, I'm going to fall out of the chair pushes me fast enough to the side that as I fall, I'm being directed by the seat to a lower spot. Now, basically, I'm in free fall through this phase, but as I'm in free fall, the car is actually redirecting my free fall. In other words, I'm falling with style. That's the premise behind that. We want to make it so that our weight, or in other words, mg, will equal the required weight, or required force, to cause the curve. Now we notice that the masses cancel right away, and we end up with this idea that v squared over r is equal to gravity. You tell me what size radius of circle you want to go on, I could tell you the velocity. If you tell me how fast you can make the roller coaster go, I can tell you how big the circle has to be so that you don't fall out. We know that from our basic understanding of physical science that if I'm at this height, say I'm at 30 feet off the ground, I should use meters, let's just use meters, 30 meters off the ground, and I go into a dive, that I can go up as high as 30 meters and I haven't broken any laws of energy conservation, right? Here I'm under the maximum height, so I'm still going to have some velocity, okay? It won't be zero, okay? The velocity is not zero, but the question is, how tight of a loop do I have to have so that that velocity that I still have is enough to keep me from leaving the cart, okay? So this is really at the heart of this question, understanding, hey, if I want to go free fall in a circle, that I've got to have a certain amount of acceleration, and it's got to be equal to gravity based on that circle. All right, so that's it for that question. Well, that was easy, Mr. Welch. The next question we're looking at is question number 8, which is kinematics and Newton's second law. So Newton's second law is F equals ma. Kinematics, of course, are using V naught, V, A, delta x, and t. All right, now listen. Most people who have an issue with this question on the test have an issue because they think of all kinematics as projectile motion questions now, and that every projectile is always in projectile motion. A question I've used in the past for this question has been a volleyball, okay, getting hit. How's that for a volleyball? Anyway, volleyball getting hit by a girl when she serves, okay? Really clunky hand. But so she's going to serve this ball. She's going to apply a force. A lot of times I'll ask questions about the impact of the hand to the ball. Maybe it's throwing a football, maybe it's throwing a baseball. And I want to know about while they're still in contact. What that means is this is not a projectile yet. Now, emphasis on yet. Yet. Eventually, once it leaves my hand, once the contact between my hand and the ball leave, yes, it becomes a projectile. But until that moment, I'm applying a force that doesn't belong to gravity to an object. I might be asking about its general motion that has very little to do with projectile motion. So I might tell you that I'm going to hit this ball, which has a 0 starting velocity. I might tell you I hit it for 0.3 seconds, okay? and I want to know how much force I'm expending on the ball. The mass of the ball is 0.25 kilograms. I don't know, I'm picking numbers out of thin air. My initial velocity should be implied that the ball is motionless before. I know that I'm going to hit it with a velocity of 13 meters per second when it leaves my hand, and I want to know the force. Well, I'm going to have to use the kinematics to find acceleration to then come over and find my force. I want you to understand that the acceleration of an object is the connection between force and kinematics. That's all that this question's about. Don't get hung up on, but it's a projectile once it leaves his hand. If it's a projectile, then the question will be about its flight, not about the contact or the forces acting on it. The only force acting on a projectile that we're going to ever talk about in this class is going to be gravity. So unless I'm asking about something and it's talking about gravity, you're not going to be looking at that type of scenario. Okay? So that's just basic kinematics with a force attachment. Let's take a look at finding the coefficient of friction. Okay? You have a box or something, it doesn't matter what it is, across a surface. Here's the deal. If I apply a force, I know that friction is going to oppose me, right? Force of friction is going to fight back with me. And the sum of the forces in the x direction, I'm not even going to acknowledge, of course, obviously we've got mg down and Fn up, but I'm not too worried about those. The sum of the forces in the x direction would be the applied force minus the force of friction. Now, they might be balanced. If the object doesn't accelerate, we say that this equals 0, and we can go along our way. If the object accelerates, then we don't say it equals 0, we say it equals ma. It's always safe to say that it equals ma, and then if it's not accelerating, you can put a 0 in for a and 0 out the mass there. If I'm asking for the coefficient of friction, I'm going to remember that mu mg cosine theta equals frictional force. Now, assuming this is a flat surface, cosine of theta goes away because theta is 0 and cosine of 0 is 1. So right here we can see where mu pops up. Now, in order to do this, you would need to know that number. How much force am I applying in order to get a specific acceleration? But if you knew that information, you should be able to calculate the mu. All right, a couple more problems. Number 10, projectile motion with a horizontal launch. It's a very simple, similar problem to the one where we did x and y earlier, but it's actually a little bit easier. The key idea here is whatever's being launched has a velocity in the x direction to begin with, and the velocity in the y direction is 0. Other than that, the problem's pretty similar. You're just going to go through your kinematics, listing off everything you know in the x side and in the y side. Obviously, that one's 0 and that one doesn't get used. And same thing that we went through with the first video. Big difference is velocity in the y direction start is 0 and velocity in the x direction will have some number associated. Other than that, it's really the same kind of problem. Not much to talk about there. Last thing we're going to talk about is satellite velocity. And we have VSAT equals square root of g times the mass of the planet. We're going to use Earth, but it could be the moon. I could put a different planet there. If I do, I have to give you the mass and the radius of that planet because it is important. And there's our equation there. Basic idea, here's the Earth. There's the center of the Earth. Here's my satellite going around. I have to measure the radius from the center of the Earth to the object. So you have to include not just the altitude, but also the radius of the Earth. It needs to be measured in meters. Okay? Measure that in meters. That's going to give us our radius. The mass of the Earth we know is 5.98 E24, and big G we know is 6.67 E negative 11. Those are our values that we're going to use for those two to be able to solve and understand, hey, how fast does the satellite got to go? Now maybe, just maybe, I give you the speed of the satellite, and I ask for the radius. The algebra is a little more complicated, but all you got to do is square both sides, and you have v squared equals GME over R. And we pull an old Welcheroo and swap those, and we're good. Good luck, and we'll see you in class.